Hello, my name is Erin Musselman, and I'm on the marketing team here at HiveMQ. Welcome, good morning, good afternoon, and good evening to everyone joining our webinar today. And now, without further ado, I'm going to pass things over to the speakers, starting with Kudzai, so they can introduce themselves and kick things off. Thank you again for joining, and I hope you enjoyed the session and the content.
Thank you, Erin, and welcome everyone to our webinar today, where we'll be talking about how to architect a unified namespace for IIoT. So today I'm joined by my colleague, Ryan, who's going to be supporting me on this webinar. My name is Kudzai Mandi Teresa. I'm a developer advocate here at HiveMQ. I do all of the evangelism around smart manufacturing, and I also provide subject matter expertise when it comes to the topic of the unified namespace and smart manufacturing in general. So I'll let Ryan introduce yourself.
Hi, everyone. My name is Ryan Duzium. I'm a solutions engineer here at HiveMQ, and I work with quite a few of our customers who are Industry 4.0 focused and using the unified namespace concept in their implementations. And so great to be here with you, Aaron and Kudzai, and looking forward to the discussion. Thanks.
Awesome. Okay, so as you all can see from the title of this webinar, really is going to be about how to architect a unified namespace. I know we've put out a lot of content over the years about unified namespace. So the purpose of this session really is to kind of like show you what exactly it looks like. So we've got like a demo simulation of a unified namespace. And the idea really here is to kind of like take you through the paces of how to build out that data structure, how to model your data, and how to kind of like really architect your unified namespace. And that we're going to do in the second half of this session. So please do make sure that you stick around for that. In the first half of this session, we're kind of like just going to start with the unified namespace principles. For some of you who have never come across the idea of a unified namespace, this is kind of like an opportunity for you to actually be on the same page as us. And for all of you who have an idea of what a unified namespace is, this is kind of like a refresher to kind of like really understand it in depth and also the value proposition of it. So we're also going to talk about a case study of one of our customers who are implementing the unified namespace, and then we're also going to open up for Q&A at the end of this session. So again, as I mentioned, Ryan is going to be supporting me throughout this session. So he's also going to be weighing in on all of the points that we're going to be bringing up as far as the unified namespace based on what he's seeing out there from our clients and all. So without further more to do, let's get started. And to kick us off here, I'll give this over to Ryan to talk about HiveMQ and our product portfolio.
Okay, thanks, Kudzai. So yeah, just a high level summary of what is the HiveMQ platform, what do we do, how does it relate to the unified namespace? And so at its core, we're an MQTT broker, and that's what you see there in the center. But that broker has lots of features in it that are in support of enterprise scale and reliability. And this is an essential component of the unified namespace because when you have a single source of truth and you need to rely on being able to get that data and get that data at scale, and while it's being moving through your organization in real time and at different levels of your network topology, these features of the broker are what bring that capability to the unified namespace. And those are namely the ability to cluster for high availability and reliable message delivery, having observability of everything that's going on in the platform with things like our control center and our metrics, being able to format that data in a way that's expected by all the parties that are tapping into the unified namespace to get that information. And then our extension system, enabling these additional capabilities on top of that architecture for things like streaming, integrating with streaming platforms, databases, different security services, and custom applications. And one of the main extensions that applies really well to the unified namespace concept is our bridge extension, which enables the unified namespace to span different sections of your network topology by bridging broker clusters together. And so I'd also mention here our HiveMQ Edge platform, which is all about being able to tap into those industrial protocols and convert that into MQTT and have that data come into our HiveMQ platform. So we've worked in quite a few industries. It's a really interesting job to have personally because we're always talking to all kinds of different customers in different verticals. We grew up in the connected car space. We have quite a few connected car customers and lots of device companies, like commercial device companies. Let's say you have a smart fridge, for example. And I consider all these things to be kind of like that Internet of Things world, where we also have an industrial Internet of Things world, where HiveMQ works with companies that are doing things like manufacturing or energy production and transportation, smart warehousing, and all those kinds of industrial use cases. And those are primarily the types of use cases that we'll be talking about today. And so I'll pass it back over to Kudzai, who's going to start us off by talking about the motivation for why you'd use MQTT in those types of use cases.
Awesome. Thanks, Ryan. Okay, so to kind of like start here, I'm sure a lot of you on this call have come across this automation pyramid, which is kind of like the way that currently all assets or production systems are arranged in many industrial settings. This is kind of like what you call the Peugeot module, where you've got different levels from level 0 up to level 5. So this is kind of like the situation or the setup that is there in the manufacturing world today. So what I want to talk about here is why do you really need to adopt the unified namespace? Because this is something that I believe a lot of manufacturers or a lot of companies still don't quite get or still understand what the value proposition is there. So based on the automation pyramid that I just showed in the previous example, the convention for traditional companies is to kind of like just continue building on top of that tiered approach of integrating systems. So what that means is that whenever you bring in a new predictive analytics app or energy efficiency app or whatever it is, the application that you're bringing into the system, you simply kind of like just include it into that tiered approach. And for you to get data from the shop floor into all those systems, this is the kind of like picture that is involved as far as getting the data out through all these different layers. As you can see, these systems have got some point-to-point integrations, and in some cases, you've got some MES systems that are not connected into a SCADA system. They still paper-based kind of like information exchange there. But the point is that for you to address a data use case, currently with this kind of setup, what that involves is many different stakeholders. You need PLC experts who know how to get data out of your PLCs. You need some SCADA experts that know how to get data from SCADA, MES experts, and also from ERP experts. So each time you need to address a simple use case, you need to go through that process. So this is a very long process for some of you who work in industrial companies. Just would take months just to kind of like really set this connectivity infrastructure just for you to get data out into a platform where you want to kind of like get value out of that data. And even if you do go through that process of setting up that connectivity infrastructure for one data use case, tomorrow you come up with a different use case, and you need to go through the step of replicating the connectivity infrastructure, which is a costly exercise and it takes a lot of time. So the time to value for a lot of companies that go down that digital transformation path can end up really leading up to years and expensive. And that's the reason why we've seen a lot of companies not really realizing value out of their digital transformation efforts, because it's costly and it takes time just to kind of like really prototype and be able to prove some concepts. Because in many cases, the data use cases or innovation within a company starts with an idea. It starts with a hypothesis to say, what if we could better run this line, or how else could we better manage these assets, right? So for you to prove a hypothesis, you want to be able to simply plug in some system and be able to kind of like do that within a matter of days. You don't want that to come to be like a 5 month long process for you to be able to prove that. And with this kind of approach, this is basically what we're seeing out there. A lot of companies that are not getting their value in time. And even if you do um, create all these data use cases and connect all these different applications together using your point-to-point data integration, what that does is it ends up creating this spaghetti architecture where you've got everything being directly connected to every other application. Your application is directly connected to devices, and they actually tightly coupled to that specific API implementation or SDK implementation. So this is a very difficult architecture to manage. This is a very difficult architecture to scale, as you can see, because you've got this whole complex setup. And if you need to bring in a different data use case or a different application, now you need to connect to more than one service just to kind of like get value out of your data. So
Yeah,
the
I'd
idea.
just to add to that, if I could, on the previous two slides, one of those big things that you were referring to, I mean, you made many good points about kind of the friction of having that, that agile way of developing on top of that data. A big piece of friction there is from a security standpoint when you're making these point-to-point connections, especially when you're connecting down in from the OT networks from the IT networks into the OT networks. What we've seen quite a bit with customers is they're bringing in their security teams or security experts to look at how they can become more agile from a security standpoint and not having to provision, let's say, every user or every application or every piece of infrastructure that needs to then access the OT data. And so that's a big hurdle we see that can be addressed with this approach as well.
Awesome. Thanks, Ryan. So yeah, the idea really of a unified namespace is to say, instead of having all these point-to-point integrations, instead of having to set up connectivity infrastructure, the connectivity infrastructure, each time you need to address a different use case. The idea of a unified namespace is to do that one-time setup where you connect all of your production assets into a common data infrastructure, which then allows you to reuse that data as you address the different data use cases that arise. This allows you as a company to be really to rapidly innovate all the different use cases that you come up with, and also be very competitive whether you're addressing energy efficiency use case or whether it's OEE, predictive analytics. Once you have all of your data in one common repository, you're then able to tap into that data or information and then be able to address all the different use cases as they arise. And the idea of the unified namespace also is that data is being published from the source, from all the originating sources into the common data infrastructure from the edge, which is otherwise known as an edge-driven idea. And what that does is that if data is actually being published from originating sources from all ends into a common data infrastructure, it then creates that snapshot, a real-time snapshot of the current state and events of your entire business. And this is very important because then it allows you to build your business models around that data infrastructure, because what you're looking at is the current state of your entire business operations or entire operations in your shop floor. And then the idea that it's based on an open architecture having MQTT as the center or as that technology that holds your unified namespace promotes this idea of an open architecture. And what that means is that as you go through your digital transformation and you start to address different use cases, you're then able to kind of like pick the best in class tools for whatever problem it is that you want to solve. So if you were doing this in a conventional approach, you say using like a vertical integrated stack, you could only deal with the tools that are at your, or that integrate with that specific vertical solution. You're not at the liberty of choosing whatever tool it is that you believe will help you really solve that problem to the best of its abilities. And also the idea that it's report by exception and lightweight, it means that this is really is a scalable and it's also very light on the wire. Now, this is kind of like a high level somewhat oversimplified view of the unified namespace where you've got your MQTT broker sitting in the middle there. And then you've got your system from the IT and your system from the IT all plugging into that common data infrastructure and pushing data there. So you're kind of like really creating a shared repository of information for OT and IT. Now, the IT side of things don't really need to know the implementation details of exactly what systems are providing that data on the shop floor side of things. They don't need to know any OPC server addresses, any Modbus registers. They are simply communicating through that data abstraction, which really kind of like really creates that decoupled approach to building your architecture, as you will see shortly when I show you the example of a unified namespace. Now, I mentioned on the previous slide that it's a oversimplified architecture because there's a lot more to it. So as you push data from all the different PLCs or systems, in many cases, a lot of PLCs don't natively support MQTT already. So what that means is that you're probably going to need some gateway or some converter that converts from one protocol and then do some contextualization and then publish that information into the MQTT broker. So essentially, there are two key components that make up a unified namespace. It is the broker itself, and then it is the what you'd call an information gateway or an IIoT platform that collects data, contextualize it, because if data is moving from one platform into the next, it definitely needs to be contextualized so that it can be interpreted in the same way across your entire enterprise. So this could be with a standalone information gateway or IoT platform, or for example, with HiveMQ Data Hub, we've kind of like started to build in some of those IoT capabilities within Data Hub itself that allows you to, for example, normalize the data or transform the data or simply do a validation of the data to see if all these producers of information are actually conforming to the predefined structure, which then kind of like really avoids technical debt downstream for downstream applications that want to consume that information. So as you can see, you are tapping into all the different systems from PLCs, flat files, SQL, or OSI Pi, or ERP, MES, whatever system it is that you want to get data from and bring into the unified namespace, you're going to need that intermediary platform that does the conversion, and then you're going to then end up with a unified namespace. So again, a lot of question that comes up when you talk about this, the idea of a unified namespace is the idea of historical access. So from a conceptual standpoint, the unified namespace itself doesn't give you history, right? The unified namespace gives you real-time data, real-time events, right? And current state, and also consumer-aligned data. So what then you need to do is to kind of like connect a historian or time series database to then tap into the unified namespace and then persist that information. Now, the big difference of having to tap into the unified namespace for historical data is that you're now consuming contextualized, normalized data and unified data, which really makes it easy for applications that need to visualize that, or if you want to train some machine learning models using that, you already have that information. This is different to a conventional approach where information is just collected from PLCs and it is pumped into the cloud to some data lake or data warehouse where it doesn't have any context whatsoever, and then kind of like shifting that problem for OT into IT. And it makes it worse because the IT folks, in most cases, they don't really know what PLC tag needs to be at what position or it's coming from what machine. So it's very important to have that abstraction that does the contextualization and persists the information into the database. And then again, you are going to have some transactional information that you need to get out of some external systems and bring into the unified namespace. So this could be, for example, you want to go into a historian and then get information like what was the rate of production in the last 5 days. And that information is important for real-time operations. So what you do is you kind of like perform that transaction and then publish that information as an event into the unified namespace. So the unified namespace holds all of that current state of your information, as you will see shortly when we go into the demo. Now, this is kind of like also a reference architecture model of unified namespace to show you exactly what potentially different components you could put together for you to build that unified namespace. So the unified namespace is more of a distributed architecture, as you can see here. And what that means is that in many cases, actually, this is what we see from a lot of our companies, and I'm sure Ryan will be happy to weigh in on this, where what they're doing is they're having an MQTT broker on each specific site that holds that local unified namespace, and then have an enterprise broker that is where all of these different sites are pushing data or bridging that information into an enterprise to kind of like give that real-time data access at an enterprise level. So whenever that there's sort of like a disruption of that connection between the edge and the cloud, they still doesn't affect the unified namespace that is actually on site. So you still operate as normal, and then data is then aggregated into the enterprise. And this is mainly for purposes whereby it's not always the case that you've got some enterprise information that needs to end down in a PLC. So that might not be of interest to an automation engineer or to a PLC that to get that information. So you've got this distributed architecture where you've got different unified namespaces that are aggregating information into an enterprise-wide unified namespace. And then you
Yeah.
have, yeah, sure. You want to jump in?
No, yeah, sure. I would just say, yeah, I mean, this is how you create that unified namespace that really spans the different levels of your network topology. What Kudzai is showing here is typically using our bridge extension to connect to different HiveMQ clusters that are not, they're not co-located. They're at different locations typically. And why is that? It's because why is MQTT used for that? Well, if you think about the Internet of Things, where you typically have like little devices, and sometimes you have mobile applications on your phones, and that's what people normally think of when they think of the Internet of Things. They think of those small devices. But what we see quite a bit in terms of the use of MQTT is not only to connect those small devices, but to connect distributed systems. And this is really what we're doing here. We have that central MQTT broker, and then we have a lot of other brokers that are distributed at different sites. And the MQTT protocol is used to connect them so that there's reliable real-time data. It's like a reliable real-time data backbone for your organization. And in that case, the things are all of these different sites, right? As opposed to a device. And so this is why MQTT is so effective in this kind of architecture.
Awesome. And then to bring in that data into that local unified namespace, again, as I mentioned, you might have an IoT platform or what you'd call a data ops layer that connects to all these different systems and then publishes that information into the unified namespace. And you might also have connectivity software like HiveMQ Edge that allows you to connect to different protocols, pull data out from Modbus, OPC UA, and also some sensors that may talk MQTT natively are able to kind of like push that data to that line level, as it were, and then that information is then bridged into that site QNS. And then you could have some systems like CAP server that may have MQTT connectivity, but they don't give you access, like you don't have control over the payload that is transmitted, or so it's simply information is being put into the broker. You then want to be able to subscribe to the broker and then recontextualize that information and publish it back, or use data hub that is built into the broker to then kind of like rename the topics, or rename the actual the payload and all things like that. And also, if you happen to have Cap Server installed, still HiveMQ Edge is able to tap into it also through OPC UA interface that Cap Server exposes. And the benefit really here of having HiveMQ do that is then you have got Data Hub also installed in HiveMQ that then allows you to filter through this data, validate the data, contextualize it at the edge before it even leaves the edge going into the broker. So that in your local unified namespace or site unified namespace, you've got all your clean data there. So again, just going to go quickly through this one. This is the picture also that shows you that in a unified namespace, again, this is also a common misconception where a lot of companies think that going the MQTT route or the unified namespace route means that they need to rip out whatever they've got and replace it with MQTT. This is basically not the case. So you're still going to have your point-to-point connections, right? You're still going to have, it's a unified namespace is a non-disruptive approach to data integration. You're simply tapping into your existing infrastructure and then publishing that data into a unified namespace. So you're still going to have some point-to-point connections on the edge. And then for integration with your IT side, this is where that data is converted into MQTT. And then as you can see, it is then placed strategically within the MQTT broker using the topic namespace to kind of like really organize it in a way that it is intuitively understood by anyone who understands the organizational structure, because that's basically how you typically structure your unified namespace. And then there's no really hard and fast rules as how you could actually name or use the MQTT topic structure to create the hierarchical levels, but there's recommendations around adopting already existing standards like the ISA 95, where you're using the enterprise site, area line, and cell convention to kind of like create buckets of information based on where your assets reside within that asset model. And then again, this is also a picture that shows you exactly how it looks like using an example company that has got different areas here, and then showing you all these different events that are being published into that specific hierarchical level. And then again, this gives you a picture of what that semantic hierarchy looks like. So you could have an enterprise level with different areas here, and then you've got different namespaces within different levels of the hierarchy. And then these are the different examples that you could see here. So maybe I think this is also a good point to then jump into the demo to show you exactly what that looks like in practice. So before we do that, I'll simply kind of like just talk through one of our customers who are implementing the unified namespace. So it's Anglian Water, which is the largest water and water recycling company in the UK. So if you want to read more about this case study here, we'll provide a link where you can then go and find out and read more about how exactly they're doing it, and also a video of them talking about why they find MQTT or unified namespace to be really transformational as to how they are improving their operations. So the main challenge that Anglian Water was really wanted to address when they were investigating the unified namespace was they wanted to really improve their customer service and also operational efficiency, and also kind of like just really the environmental performance. And this meant that they needed to bring all this data from all these disparate sources into a single source of truth, into that one common repository of information, where then they could be able to tap into that information and be able to address all these different use cases or objectives that they want to do. So the solution, again, was to kind of like use HiveMQ as that platform, that data infrastructure to which they collect MQTT information and publish it and build that unified namespace or that single source of truth of data that allows them to then tap into that information, whether it's IT or OT side of things, that are able to share that information and then be able to rapidly innovate to address all these different use cases that they wanted to address. And the result that they got out of that really was that they now are getting a better insight into the performance of their assets. And then also, as I mentioned, that integration between IT and OT environments, that friction has been eliminated. Now we've got this seamless kind of like interaction through this abstraction. And then also, as Ryan alluded to, this really helps them maintain a high level of security. Okay, so now let's quickly jump into the demo. Okay, Ryan, just give me a thumbs up if you can see my screen. Awesome.
Go.
Okay, so what I'm going to show you right now is a live unified namespace. So this data is simulated. And then this kind of like really is meant to kind of like give you an idea or a guidance as to exactly how you could architect your unified namespace. And then this will also really connect the dots if you're still struggling to understand what the unified namespace is like concretely, right? So what you see here is an MQTT Explorer. So I'm connected to a HiveMQ broker using MQTT Explorer. And then here I've got a namespace that is being published into that specific broker. So as you can see, I've got a fictional company here called Global Industries. And this company could have many sites, but here we're actually showing one site, which is Munich. So it could have many different sites across the world. So now if we go into Munich, so this is a simulation of a batch plant. So typically in a batch plant, you've got different areas of production. You've got your blending area, you've got your storage area, you've got your filling area, and you've got your packaging area, and you could have many more areas. Now, this is also a very important part to mention the one of the compelling aspects of the unified namespace. This idea of automatic data discovery or automatic discovery of information. So as you can see here, I've got a Munich site, and under Munich site, I've got 4 areas. Now, suppose we've just commissioned a new area within that specific site. So as soon as you plug in information from that site, it will automatically show up here. So what that means is that across your entire enterprise, whoever is connected to that one broker endpoint can immediately be notified or discover that a new area has actually been commissioned into line. Now, think of the savings in both time and cost if this had to be done manually to kind of like really discover all of this information from different areas of an enterprise, whether it's OT or IT. Now, by subscribing to that MQTT broker, that unified namespace, we're able to automatically discover all lines, all PLCs, everything that is plugged in. It will immediately show up here, and you can immediately consume information. So that's the first big compelling thing about the unified namespace. Now, again, there's no really hard and fast rules around the unified namespace or exactly how you need to structure it. So this could be different areas that you are mentioning here. So if I go into the blending area here, you could see I've got line 1. So I could have many lines again. So I could have line 1 up to line 5. So depending on what is the current reality within your shop floor. So if I go into line 1, so now as you may already see that I'm actually following that ISA 95 enterprise site area line. So once you get into your line, again, you want to have, first of all, a namespace where you're getting all of your raw data. So as I mentioned previously, you're not always in control of the MQTT data that is incident on your broker. So you want to have a namespace. So if we go into Edge here, I've got a namespace that is coming, say, from HiveMQ Edge. So suppose I've got a HiveMQ edge installation in my factory, and I've got MQTT messages that are being converted, say from OPC UA, and then they're being converted by HiveMQ edge, and they're being published into the MQTT broker. I may not already know what I want to use that information for. That's the whole idea of the unified namespace, is that you don't make assumptions about what you're going to do with that data. You collect the data and range it in a semantically understood namespace. And then as you discover the problems, as you kind of like conceptualize your data use cases, you're then able to find the information that you need in a matter of minutes or seconds, literally, just to get that information and then be able to address all the different use cases. So if I go into HiveMQ, for example, here you could see I'm connected directly to PLC tags. So this could be coming from OPC Modbus, but now I have them under the HiveMQ namespace. So I've abstracted all of that industrial protocols. All of this information is actually coming through as information that is coming through from HiveMQ. But as you can see, these are all still just discrete data points, right? Even though they've now been abstracted. So same applies if I go into CAP server. I've got data that is also coming through from my CAP server instance. And again, these are all discrete components. But again, here you'll notice that here I might have, for example, here in my simulation of a batch plant, I've got level transmitters for my silos. I've got 4 silos, and then they've got level transmitters. As you'll see here, I've got LT01 up to 4. This is, as you know, some of you work in the automation space, this is typically how an automation engineer would name things inside the PLC. So this might be coming from a system where you've got no control over how that information lands in your broker. So you want to first put that information in that namespace where you know this is data that is coming from my CAP server. This is the naming convention. But now, once you've got all of your information here that is coming from all these different systems, you now want to create some consumable information. You now want to create some namespaces, as it were, some functional namespaces that allow this information to be readily consumed by many different applications. So the first example here that I have is to say, now in your line, perhaps you've got a mixer, right? I've got a mixer in that specific line. Now I've created a mixer 1 namespace. So I could have many mixers there. So if I could go into mixer, I can then find out all of the information about this specific mixer. So I could go and find out the process parameters. What is the process parameters that are currently going on in the mixer? So I need to find out what is the agitator speed for my mixer. I need to find out what is the current weight. So this is information that will be coming through a load cell or whatever measurement mechanism you're using to measure the current product that is within the mixer. I need to find out the temperature of the product, the pressure of the product. So these are the process parameters. Now, this is information that could be coming from that raw data that I'm collecting from using HiveMQ or CAP server, or it could be data that is coming from an IIoT platform that has been contextualized. Now, you could see here now I'm giving it names where it's now agitator speed or weight. It no longer has that PLC kind of like convention about it. And this data is now being published for the sole purpose of consumption. So this could be the data that is of interest to a process engineer. So a process engineer wants to get these parameters, then they know that if I need to know about process parameters of mixer 1, this is where I go to get that information. Now, think about the power of that information to say, if I'm a process engineer, I don't need to know anything about the source of the data. All I need to know is how our organization is organized semantically. I know I need to go into Munich. I know I need to go into blending area. I know I need to go into line 1. I know I need to go into mixer 1, and then I'll find the data that I need to then do whatever it is that I want to perform, whether I just want to historize this information or I want to trend it, and then I want to correlate this information with data that's coming from another mixer in the same plant or in a different plant. I've got all of this information already in a functional namespace that allows me to use that information straight away without having to rely on anything else. And again here, I've got machine parameters. Here I've got data about a specific machine. So this could be of interest to a maintenance engineer who wants to get information about this specific meter. What is the current state? What is the vibration of this mixer? What is the speed of this mixer? So as you can see, this is maybe might not be information that is of interest to a process engineer, but now it has been created for the sole purpose of consumption by a maintenance engineer or whoever is interested in this information about the machine itself and not the process. So as you can see, now we are reusing your data to create different functional namespaces for different consumption use cases. So again, you could have batch events, you could have alarms, whoever is interested in consuming alarms, and you could also have machine information about the specific machine. So you want to know about the serial number, or maybe you want to put some calibration information. When was it last calibrated? Who calibrated it? So, I mean, as you start to think about this whole thing, you're finding all of this information that you'd care about irrespective of who you are, OT or IT, you find all of that information in a semantically understood arrangement and in a way that it has already been contextualized and normalized. And if it so happens that you have got a predictive analytics application, so you want to perform some predictions on your mixer or the component of your mixer, you want to know when a specific motor is going to, or when a specific mixer is going to fail, or you want to kind of like monitor that, you're then able to create a predictive analytics namespace within the mixer itself, so that a predictive analytics application that wants to monitor the condition of all motors for all mixers knows exactly where to go to find the information it needs to perform that. And then here, again, you can see that this data model has been created for the sole purpose of being consumed by a predictive analytics application. So I'm calculating the average current, the vibration, and then I'm also specifying what is the current material that is being produced. So maybe this information is important. Maybe the viscosity of the product is what's causing the mixer to fail. I don't know. So that information, the power of the unified namespace is that it allows you to arrange information based on how you want to use it. Now, bear in mind, this is information where you've defined the structure, you've defined these events, you've defined these models once and only once. And now we are reusing this information and creating for many different data use cases. You can already imagine the speed at which this really allows you to move from one use case to the next, from one use case to the next, by simply just connecting to one endpoint, you are discovering all of this information. So again, here we've got a visualization namespace. So again, we're in this specific mixer or a specific line. So maybe you want to visualize information consistently across your line. The automation engineers don't need to connect directly to the PLCs and kind of like build dashboards how they imagine they need to be built. You could standardize on how information needs to be visualized for each specific line, for each specific site, for each specific mixer. All they need to do is to kind of like go into that visualization namespace and then pull the data that has already been pre-packaged for them, and then they're simply just displaying it there. And if you happen to actually be working on a SCADA system that supports MQTT, like say ignition, this literally boils down to drag and drop. So an engineer is simply just dragging these visualization tags and dropping them onto a canvas, and then just choosing what visualization widgets they want to able to do to do that. So this kind of like really shows you the power of the unified namespace, like being able to create all these different namespaces. So also, if you could monitor the Q&A there for me, Ryan, because I want this to be interactive. I want to find out if there's anyone who's asking questions about what we are currently showing now, right now, so that we could address it while we are here. So again,
Absolutely.
here, if I go out of the mixer here, so within this edge namespace here, I've also got waste. I can monitor exactly how much amount of waste that is being produced in this specific edge namespace. And then,
Uh, Yeah,
yes.
because I'd say a lot of people are asking about what you mean by an IIoT platform. Like what qualifies something as being an IIoT platform, and maybe you could give some examples as well.
Yeah, that's actually a good question. So IoT platform is kind of like really a broad term, but what I would say is basically it's a platform that allows you to connect to legacy systems and also some modern systems, bring that data into that specific platform, and then add context to the data, rename the data, normalize the data, and unify the data and perform all kinds of transformations on the data or data messaging that you'll be able to imagine. And also, to some extent, be able to buffer the data in case there's some kind of loss in connectivity with the MQTT broker. So it is those capabilities that an IIoT platform will be able to provide. So an example would be, for example, Ignition could be considered an IoT platform because it allows you to connect to all the different systems and perform these transformations, create data models. Because also the other thing that you want to be able to do within a platform is to say data that is coming out of all these different PLCs exists in as discrete data points. And you want to be able, before you actually publish your data to persist in a database or whatever you want to do with that data, you want to be able to kind of like unify the data to say, this is the data that is coming out for mixer one. So you want to be able to define to say, how does a mixer look like? So a big part of it is that as an organization, you're going to sit down and say, how best could we represent a mixer? How best can we represent a pump? And then you're going to create a definition of that standard to say, this is uh, what we expect of a pump. We expect these certain properties from a pump. And then an IoT platform then allows you to define those models and then create instances of those models and then map those to the actual data point that is coming out of the PLCs and then plug these or push these into the namespace in a level where it makes sense for that data to live. So as you can see, the IoT platform is responsible for creating two types of data products. First of all, data products that reflect the current operational state, the current state of your operational systems. So this could be a pump. These are the properties of a pump, and these are the values of a pump at any given moment. So that data could be persisted on a database, and then it could be aggregated at a later point for value, or it could be used to train machine learning models. And then the other aspect is that you're creating some consumer aligned data product. That is a data that is created not necessarily to reflect the current state of your business, but for the sole purpose of being consumed by another application. So this really removes that friction where data needs to end into a data warehouse first, and then you need a data science team to perform some ETL transactions, which could take 3 weeks, and then they get that data product, and then they share it with you, and then say, oh, this is the data product that I need to train my model. Now you've got a platform that allows you to create all these different data products. So that's basically what an IoT platform could be. Examples include HiveMQ also is another data platform. And then also, as I mentioned, it's now that line is now starting to kind of like become sort of like a gray line where a lot of these IoT platform capabilities are now starting to be built into the broker itself. For example, Data Hub is now starting to build those IoT platform capabilities. So I don't have a clear answer for exactly
Edge
what
as
an
well,
IoT
I guess,
platform
right?
does.
Like HiveMQ Edge as well would be like part of the picture that might be considered something that's sort of having IIoT platform features kind of coming into a broker type architecture.
Exactly.
Yeah.
So HiveMQ Edge also because it's got the connectivity to all the different PLCs, and then it's also got this IoT platform capabilities with Data Hub, allows you to perform all of this normalization and contextualization of data. So that's basically what really makes up an IoT platform. So it's a broad set of capabilities that it needs to support.
So thanks for that, Kudzai. So the what we're looking at here with MQTT Explorer, someone was just asking, how does this data arrive in MQTT Explorer? Like, what's the mechanism by which you are kind of connecting and pulling in this data?
So again, that's the beauty of MQTT. So all you need to do is to really so I'll quickly show you the connection here. So as you can see, what I did, I simply specified the broker URL address, port number, username, and admin, and then it will bring that namespace. But then now, obviously, the application itself needs to have the capability of then kind of like rendering that hierarchical view of uh, 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 the unified namespace. So there's other tools also like mqtt.fx that allows you to connect to an MQTT broker and then do the same thing. Ignition also allows you to connect to an MQTT broker, bring that namespace just for the sole purpose of you being visualized, to be able to visualize that. But it exists, that hierarchy exists, whether you visualize it or not, it exists within the broker itself. So if you know what topics you want to subscribe to, so if I've got a predictive analytics application that say wants to subscribe to say here again to this mixer, it then needs to kind of like specify this specific topic path. So not every application needs to get the entire namespace like MQTT Explorer and view it. Of course, for diagnostics purposes or for visualization purposes, as you build your unified namespace, it really helps for you to visualize what your structure looks like. But as you start to consume, you're going to be consuming it at different points of the namespace. So you're simply specifying that specific topic path, whether you're using also wildcards to subscribe to multiple levels or everything under a level. This is kind of like the power that MQTT gives you to be able to perform that kind of subscription.
Because I do know if BACnet is supported in HiveMQ Edge. I think we were adding it. We've either added it already or we're adding it very, very soon.
So it's not yet supported, but it's actually the next one in line
Right.
to be released. So that's coming up very soon.
Okay, great. We had another person asking, where does Sparkplug come into this whole picture? Is all of this that you're showing, is it Sparkplug compatible?
Yes, it is. Yes, it is. So what I've just done right now is that I've activated Ignition to publish a Sparkplug namespace into this MQTT Explorer, into that broker, which I've pulled here. So as you could see, Sparkplug now exists within the broker with its own namespace. So because obviously the Sparkplug it's got a protobuf encoding as far as the payload is concerned, and then also it's got a consistent way of representing the topic structure. So how we think about Sparkplug currently is that you use Sparkplug from level 0 up to 2, like sort of like your SCADA a network, because it's got all this goodness as far as like device management capabilities are concerned, automatic discovery of tags. So you would have a namespace within the broker for the sole purpose of really maintaining that SCADA functionality. So whether you're using Ignition or whatever SCADA platform that supports Sparkplug, we're able to have isolated SCADA layer that uses Sparkplug. And then as soon as you want that data to be available in your global unified namespace or a flat MQTT unified namespace, you're then able to use, again, an IoT platform to subscribe to that Sparkplug namespace and then unpack it so that it's actually a flat MQTT namespace and then republish it into the unified namespace. So, for example, here, as you can see, I've got a refrigerator that is in the packaging line that is publishing Sparkplug payload. So I could subscribe to this refrigerator here from Sparkplug namespace, and then I could then go into my unified namespace, and then here I'll be then able to, to publish this data in flat MQTT here. So I'm taking from the Sparkplug namespace, I'm putting it into a unified namespace. So now you've created that bridge between your OT and IT. You're getting the goodness of Sparkplug for your OT SCADA capabilities, and you're also getting the advantages of being able to then integrate that directly with your MQTT platform. So again, as I mentioned, that functionality is also built into HiveMQ Data Hub that allows you to unpack Sparkplug from protobuf into JSON, and then you republish it into a flat MQ or vanilla MQTT topic namespace within your unified namespace. So those are also the capabilities that a platform, IoT platform would do, or a platform such as HiveMQ Edge, which has Data Hub, would allow you to unpack those spark plug metrics into the unified namespace.
Thanks for that. So we have had a lot of questions about security and securing the namespace, let's say, in terms of who can publish to which topic, who can subscribe to which topic. Obviously, this is a very, very important subject when it comes to the unified namespace, because a big part of being able to trust that data is that you know that the client that's published it has been authenticated, and that that client has the right role within the system to be able to modify that data so that you know it's coming from a reliable source. The way that the HiveMQ platform supports this is through our enterprise security extension. So it has capabilities to enable clients to authenticate using different third-party sources, like you may have LDAP or OAuth or other, mutual TLS, so client-side certificates, lots of different ways of authenticating clients. And what's nice about the way that this extension works as well is that you can even extract properties from that authentication method and use it in your authorization or your permissions for that device. So if that device has a particular name and that name is part of the certificate that's been given to that device in order to operate, you can extract that name and use it within the topic structure that the device is allowed to publish into. So you can even keep devices, within their own kind of sandbox within that unified namespace, and just creating that kind of reliable trust chain from authentication to authorization to consumers of the data with that method. I had another question here for you, Kudzai. So somebody said, what are the best practices for architecting a UNS, like in terms of the path structure? I think they're meaning the topic structure here. And how do you keep it, flexible and adaptable and make it easy to use, let's say?
Yeah, so as I mentioned, that the whole idea is to say you structure it according to how your organization is already organized. So in most cases, for a lot of companies, your organizational structure already exists within your ERP system. So whatever hierarchical structure or asset sort of like modeling structure you've got within your ERP system is what you need to replicate for your unified namespace. Because the whole idea is to say you want it to be kind of like semantically discovered intuitively for any application that's interacting within your enterprise. It needs to kind of like really understand how that information is structured. So there's no standard way of doing that. The whole idea is to kind of like structure it according to how it makes sense for your business. That's the whole idea, to kind of like really create that. So obviously, if your business is following ISA 95, then naturally this is what you want to follow. Or if you don't have a structure already, ISA 95 is a good place to start.
Okay, great. And so when it comes to an MES system and information coming from there, I assume your answer would be very similar in that regard. It depends the answer is essentially it depends, and it's based off of your organization's structure, let's say.
Exactly. So again, here you could see on line one, I've got an MES system. This could be at area level, but here I've got it on the line level. And then because this is where I'm actually kind of like monitoring my production efficiency within this namespace. And then also you could see on ERP, I'm actually publishing data from the ERP system into this ERP namespace at line level. This could be at site level if it makes sense for your business for that information to live a site level. But the whole point is that now the MES and ERP, which typically communicate to each other using direct SDK or API, now they're just communicating through this abstraction. You could change your ERP system and the MES wouldn't know or doesn't really care because that information is available through the namespace.
Okay, thanks. How are we doing on time, Aaron?
We are at time. I think we could just do one more question and then wrap things up.
Okay, sure. I have one here, which is just, you know, is there any specific infrastructure that's required to manage the enterprise UNS? Um, well, uh, when typically we're dealing with customers that are looking to put their UNS on MQTT and HiveMQ, and so I'll just answer that question from the perspective of where you can deploy and operate the HiveMQ platform, which is really all pretty much anywhere. You can deploy it on Linux, you can deploy it on Windows. You can use Docker containers. You can use Kubernetes, and Kubernetes is becoming, well, already has become a very popular choice. And one of the reasons for that is based off of our availability of a Kubernetes operator, which takes care of common operational tasks to make it easy to manage HiveMQ, to have very low overhead in doing so. Things like being able to recover from a failure in terms of restoring a node in a cluster, or doing an upgrade without any downtime during that, which is normally called a rolling upgrade, where a one node is upgraded at a time. So lots of great deployment options, and we also have managed offerings as well, where we run the platform for you in your cloud of choice. So lots of different options there.
Awesome. So many questions. If we don't get through to your questions now, we'll definitely reach out to you and answer all those questions. And if you need to contact us directly for more information, also please feel free to do so.
Yes,
Erin,
exactly,
over to you.
mirroring that. Thank you all for joining today. This was a fantastic webinar. Great content, great questions all around. So thank you again for joining. You'll receive an email later this week with the recording of the webinar in case you'd like to watch it again or share it with any of your colleagues. And you'll also receive a copy of our new ebook. Thanks again, and we hope to see you at a future HiveMQ webinar. Have a great week.
Thanks, everyone.